Commons-based peer production is a term coined by Harvard Law School professor Yochai Benkler. It describes a new model of socioeconomic production in which large numbers of people work cooperatively. Commons-based projects generally have less rigid hierarchical structures than those under more traditional business models. Often, but not always, commons-based projects are designed without a need for financial compensation for contributors. The term is often used interchangeably with the term social production. Overview. Benkler contrasts commons-based peer production with firm production, in which tasks are delegated based on a central decision-making process. Benkler first introduced the term in his 2002 paper, Coase's Penguin, or Linux and the Nature of the Firm, whose title refers to the Linux mascot and to Ronald Coase, who originated the transaction costs theory of the firm that provides the methodological template for the paper's analysis of peer production. The paper cites Eben Moglen as the originator of the concept. In his book The Wealth of Networks, Benkler significantly expands on his definition of commons-based peer production. According to Benkler, what distinguishes commons-based production is that it doesn't rely upon or propagate proprietary knowledge. The inputs and outputs of the process are shared, freely or conditionally, in an institutional form that leaves them equally available for all to use as they choose at their individual discretion, to ensure that the knowledge generated is available for free use. Commons-based projects are often shared under an open license. Not all commons-based production necessarily qualifies as commons-based peer production. According to Benkler, peer production is defined not only by the openness of its outputs, but also by a decentralized, participant-driven working method of working. Peer production enterprises have two primary advantages over traditional hierarchical approaches to production. Information gain. Peer production allows individuals to self-assign tasks that suit their own skills, expertise, and interests. Contributors can generate dynamic content that reflects the individual skills and the variability of human creativity. Great variability of human and information resources leads to substantial increasing returns to scale to the number of people and resources and projects that may be accomplished without need for a contract or other factor permitting the proper use of the resource for a project. In Wikinomics, Don Tabscott and Anthony D. Williams suggest an incentive mechanism behind common-based peer production. People participate in peer production communities, they write, for a wide range of intrinsic and self-interested reasons. Basically, people who participate in peer production communities love it. Commons-based peer production refers to any coordinated, internet-based effort whereby volunteers contribute project components, and there exists some process to combine them to produce a unified intellectual work. CBPP covers many different types of intellectual output, from software to libraries of quantitative data to human-readable documents. Principles. First, the potential goals of peer production must be modular. In other words, objectives must be divisible into components, or modules, each of which can be independently produced. That allows participants to work asynchronously, without having to wait for each other's contributions or coordinate with each other in person. Second, the granularity of the modules is essential. Granularity refers to the degree to which objects are broken down into smaller pieces. Different levels of granularity will allow people with different levels of motivation to work together by contributing small or large-grained modules, consistent with their level of interest in the project and their motivation. Third, a successful peer production enterprise must have Locust Integration, the mechanism by which the modules are integrated into a whole end product. Thus, integration must include both quality controls over the modules and a mechanism for integrating the contributions into the finished product at relatively low cost. Examples: Examples of projects using commons-based peer production include Linux, a computer operating system kernel; GNU, a computer operating system, generally used in conjunction with the kernel Linux; Slashdot, a news and announcements website; Wikipedia, an online encyclopedia; distributed proofreaders, which proofreads public domain e-texts for publication on Project Gutenberg; SETI at Home, a project which searches for extraterrestrial life; Kuro5hin, a discussion site for technology and culture; Clickworkers, a citizen science program; SourceForge, a software development organization; Sensorica, a hardware development network organization using the Open Value Network model; RepRap Project, a project to create an open-source self-copying 3D printer; Pirate Bay, a shared index of BitTorrents; OpenStreetMap, a free map of the world; Appropedia, a project for development of open-source appropriate technology; WikiProgress, a project for collecting information and data on measuring the progress of societies; Ushahidi, crowdsourced maps; Growl, a degrowth education network producing open materials and curricula; Community Garden, where people work together to grow things and then share the fruits of their labor; Outgrowths. Several outgrowths have been customization, specialization. With free and open source software, small groups have the capability to customize a large project according to specific needs. Longevity. Once code is released under a copyleft free software license, it is almost impossible to remove it from the public domain. Cross-fertilization. Experts in a field can work on more than one project with no legal hassles. Technology revisions. A core technology gives rise to new implementations of existing projects. Technology clustering. Groups of products tend to cluster around a core set of technology and integrate with one another. Related concepts. Interrelated concepts to commons-based peer production are the processes of peer governance and peer property. To begin with, peer governance is a new mode of governance and bottom-up mode of participative decision-making that is being experimented in peer projects, such as Wikipedia and FLOSS. Thus, peer governance is the way that peer production, the process in which common value is produced, is managed. Peer property indicates the innovative nature of legal forms such as the general public license, the Creative Commons, etc. Whereas traditional forms of property are exclusionary, peer property forms are inclusionary. It is from all of us, i.e., also for you, provided you respect the basic rules laid out in the license, such as the openness of the source code, for example. The ease of entering and leaving an organization is a feature of adhocracies. The principle of commons-based peer production is similar to collective invention, a model of open innovation in economics coined by Robert Allen. Also related, open-source economics and commercial use of copyleft works. Criticism. Some believe that the commons-based peer production vision, while powerful and groundbreaking, needs to be strengthened at its root because of some allegedly wrong assumptions concerning free and open-source software. The CBPP literature regularly and explicitly quotes FOSS products as examples of artifacts emerging by virtue of mere cooperation, with no need for supervising leadership. It can be argued, however, that in the development of any less than trivial piece of software, irrespective of whether it be FOSS or proprietary, a subset of the participants always play explicitly and deliberately the role of leading system and subsystem designers, determining architecture and functionality, while most of the people work underneath them in a logical, functional sense.